Students, this is Unit 8, Lesson 8.2, Area of Regular Polygons. You should have your preview notes in front of you. Don't forget the date, time, and location. Of course, most of you are watching this at home, still expecting to get some sort of supervisory sign-off there. Okay, let's take a look at what we're learning today. Things you want to have on hand: calculator, colors, pencil, of course. Review: acute triangle, obtuse, right? The word regular, and then here's a new word, apothegm or apothegm, depending on which dictionary you look it up. That's a new word. Radius, you associate the word radius with circles. We're going to be using radius for polygons. So before we get into what regular polygons are, let's do a quick recap of how we find the area of a triangle. In a triangle, the area is base times height over 2. And the base and the height always makes a right angle. What's super important to understand is that in a right triangle, taking a look here, in a triangle, your base and height always make a right angle. So in an acute triangle, that altitude is inside. But when you make it a right triangle, that altitude becomes one of the legs. And in an obtuse triangle, the altitude goes outside. So that's what's important to understand, is that the altitude changes depending on the situation. So in an acute triangle, our base would be here, and our height, again, at a right angle, would be right there. Base times height over 2 is the area of a triangle. In an obtuse triangle, this would be the base, and then to make a right angle, you actually have to be outside the triangle. So your height would be out here at right angle to the imaginary extension of the base. And in a right triangle, the base and the height itself are the legs. So it's important to understand how the base and the height relationships change in a triangle, depending on the scenario. So it says, read out loud please with me, finger right there. The area of a right triangle is 6 centimeters squared. The longer leg is 4 centimeters. Find the length of the hypotenuse. Let's draw what we have. We're given the area. The area is, that's an important piece of information, area is 6 centimeters squared. Another piece of important information is the shape itself is a right triangle. Area is, and cross that out. The longer leg is 4 centimeters. So the longer of the legs is 4 cm. It's asking, what is the length of the hypotenuse? That's the ultimate question. What is the length of the hypotenuse? Always start with what you have. Never focus on what you're looking for. Focus on what you have. We have the area of the triangle. So let's at least write out the area equation. In this case, the area is going to be one leg times the other leg, because base times height in a right triangle are the legs over 2. Let's circle, plug, chug. Our area is 6. So we have 6 right here, equals one leg, the shorter leg that we do not know, times the other leg that we do have. over 2. We're going to cross multiply. We're going to divide that 4 out. And we get an unknown leg as 3 cm. Now, careful, that is not what's being asked for. The hypotenuse is being asked for. So now we do leg squared plus leg squared equals hypo squared. Leg squared plus leg squared equals hypo squared. And we solve. That's going to be 9 plus 16, that's 25, equals x squared. The opposite of squaring is square rooting. Therefore, our hypotenuse is 5 centimeters. So, in solving for the hypotenuse, we did not originally look for the hypotenuse. We always start with what you've been given. And we were given the area. Ready? This page, you're going to do this on your own. Work in pencil. Then restart the video and correct in red pen. Pause. Welcome back. Hopefully you actually did this on your own and you're not just copying, because copying is not learning. So our area equation for both of these is area equals base times height over 2. So here our base would be 12, our height would be 4 over 2, and we get 24 millimeters squared. Here our base would be 5. Our height is 3. And that would be 7.5 centimeters squared. No, you were not wrong just because it was a decimal. Taking a look here, it says the area of an obtuse triangle. So we're going to draw an obtuse triangle. Is 72 cm squared. The height is 6. So we drop down the height. Is 6 cm. Find the length of the base, which we don't know. Call that x. So area equals base times the height over 2. That's 72 equals unknown base times the height, which is 6 over 2. I'm going to take that 2 into the 6. I get 3. So I have 72 equals 3x. Divide by 3. Three goes in there twice. So we know that our base, in this case, is 24, check for units, cm. Okay, the reason why we reviewed triangles is because triangles is very closely related to regular polygons. Triangles is very closely related to regular polygons. So first, let's simply define what makes a polygon regular. If you look here, you notice all equal sides, which implies all equal angles. That is what makes it regular. It's a polygon with all congruent sides and angles. So what we're about to learn only works for regular polygons. It's important to understand that. It only works for regular polygons. Before we move in, I need to go over a few vocabulary words. All regular polygons have a center. So that would be considered the center. A radius is the segment that connects center to corner. Center to corner. So that would be a radius. That would be a radius. All of these, what I'm connecting, are radii. Center to corner, radii. Radius, center to corner. And then the new word is the apothem. That goes from the center to the midpoint of a side. Center to the midpoint of the side. That's called the apothem. And it hits the midpoint, and it also always creates a right angle. So the apothem or apothem always starts from the center, goes to the midpoint, and creates a right angle. Make sure you don't mix these up. Center, corner, radius. Center, midpoint, apothem. Once again, center, corner, radius. Center, midpoint, apothem. So those are our three key vocabulary words: center, radius, and apothem. When you work with regular polygons, you're going to be asked to find the perimeter. One key thing, I always want you to physically trace perimeter. Never use your eyeballs. Physically walk it around. Watch, like this. This side is 8, so I walk it around. I realize that's 8 sides, so my perimeter is 8 times 8, which is 64. I check units, no units, and it's singular because it's just length. Notice I always put a little arrow when I'm doing perimeter. Super duper important. You always physically trace and count the sides. Never just trust your eyeballs counting. So that's 9 times 10.2. And it's just singular units because perimeter is strictly length. Always physically trace perimeter. Now, just to recap, area of a triangle. Any triangle, that area is half a parallelogram. So area equals base times the height over 2. Key component. Height always creates a right angle. Keep that in mind. That's a triangle. Base times height over 2. Over 2, it's half a parallelogram. So area of a triangle is going to be base times height over 2. Take a very close look at this image here. Very close look. All regular polygons are simply a series of congruent triangles. In fact, they're isosceles congruent triangles because the radii are all equal. So you have a series of congruent triangles going all the way around. Now, I'd like you to trace with me. Let's trace the bases of all the triangles together. Ready? That's one base. Keep going clockwise. There's another base of the next triangle. Another base of the next triangle. Another base. Another base. another base. Do you see all the bases together of the triangles, these individual triangles? All the bases together is actually the perimeter of the shape. And if we focus in on this one triangle, the height of the triangle, center to midpoint, is actually the apothem of the polygon. So the height is actually the apothem. So it leaves us to this equation. Area of a single triangle is base times height over 2. Area of a regular polygon, which is simply multiple triangles. Multiple triangles combined together. That base is going to be the perimeter. And the height of a singular triangle is the apothem over 2. So area of a regular polygon is perimeter times apothem over 2. We replace the base with the perimeter because it's multiple base triangles. The height is actually the apothem. So we're going to do a couple problems together here. It says find the area of the following shape. Okay, we write our equation. Area equals, it's a regular polygon. Area equals perimeter times apothem over 2. So step 1, let's get our perimeter. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So our perimeter is going to be 9 times 10.2. And our apothem, center to midpoint at a right angle, is going to be 14 over 2. Now that you have all your plugins, now you may grab a calculator. Do not grab a calculator until you have all your plugins. So we're going to go 9 times 10.2. We already did this. That's 91.8 times 14 divided by 2, 642.6. Check for units. We don't have units, so we're just going to say units squared. Perimeter times apothem over 2. Let's take a look here. Let's read out loud. A regular hexagon has an area of 680.4 centimeters squared and a single side length of 16.2. Find the length of the apothem. Let's take this one step at a time. Step 1, we know it's a hexagon, which is a 6-sided shape. And all the sides are equal because of that word regular. It has an area of 680.4 centimeters squared and a single side length of 16.2. Find the length of the apothem, which we don't know. So the apothem is what we do not know here. Start with the equation. Area equals perimeter times apothem over 2. Now we circle, plug, chug. We have the area. Our perimeter is not 16.2, that's super important. Remember, perimeter, we always walk around. 1, 2, 3, 4, 5, 6. That's our perimeter. So our perimeter is going to be 6 times 16.2 times our unknown apothem over 2. We'll go ahead and reduce that 2. I'm taking it into the 6. I could have taken into 16.2. It doesn't matter. Either way, I get 3. Okay, so now I'm going to do 3 times 16.2. And I get 48.6. So I have 680.4 equals 48.6 times our unknown x. To solve, of course, we are simply dividing. We have 680.4 divided by 48.6. And we get our apothem. Whoops. Try that again. 680.4 divided by 48.6. There we are. 14. Our apothem is 14. Check for units. 14 cm equals our apothem. This page you're going to do on your own. Work in pencil. Pause the video, then restart. Welcome back. So let's see how you did. You should have gotten here, your area equals 440. Check for units, no units, units squared. Taking a look down here, we have area equals perimeter times apothem over 2. Here, that area goes right there. We want to find a single side length, so I have 452.735 equals my perimeter. I don't know a single side length, but I do know the number of sides. 1, 2, 3, 4, 5, 6, 7. So it's 7 times x, because I don't know what the length is, times 11.7 divided by 2. So I'm going to go 7 times 11.7 divided by 2. I get 40.95. So 452, 735, 40.95 times our unknown x, which is a single side. Therefore, it's going to be 452.735 divided by 40.95. And you get approximately 11.06. As a single side length there. Check your work. Go back, verbally reflect on what you've learned today.